Alright, so this video is going to be part 1 of more cross-product practice. Okay, this video we'll be doing some practice using the cross-product to find various things, okay? And this is directly off of the video that we did on just some more uses of the cross-product, okay? So, we want to find the angle between the vectors 1, 3, 1 and 4, 2, negative 1, okay? And we've been able to do this with the dot product, but now we're going to do it with the cross product, okay? So first, to be able to use this formula, sine theta equals the magnitude of A cross B over the magnitude of A times the magnitude of B, we need to find the magnitude of A cross B. Okay, that's the first step. Now, if we want to find the magnitude of A cross B, we need to set up our, first we need to set up our 3x3 matrix, okay? We need to set up our 3x3 matrix, okay? And I'm not going to have this equal. Let's just do A cross B. There we go. That'll be equal. And we'll have this be, well, we have to put our unit vectors at the top. And then we put 1, 3, 1. And 4, 2, negative 1. Okay? Now, to solve this 3x3 matrix, the first thing that we're going to have to do is put our I hat here. And we find the determinant of this 2x2 matrix here. 3 times negative 1 is negative 3. And then we're going to subtract 2 times 1, which is 2. Okay, we do minus j hat. And we have 1 times negative 1, which is negative 1. Then we have minus 4 times 1, which is just going to be 4. Okay, then we have plus k hat. And that's going to be, we're going to have a 1 times 2, which is 2. Minus 4 times 3, which is 12. So we have a 2 minus 12. All right, now we're going to just kind of simplify this a little further. We'll get I hat times, actually, let's write it more like this. Here, let's write it like we have a negative 5 I hat. Then we have a minus, we have a negative 1 minus 4 in here, so we have negative 5, and this minus will make it plus, so we'll have a plus 5 j hat. And then we have minus 10 k hat. Okay, so our vector is, and this is our vector, but we can write it in angle bracket form as well. So we can write it as negative 5, comma 5, comma negative 10. Okay, so now we found A cross B. We need to find the magnitude of it. So we need to find the magnitude of this. So the magnitude of A cross B is going to be equal to, well, now we do the distance formula with this vector, okay? So we need to do the sum of the squares and take the square root of that. Now, we have a negative 5 squared plus a 5 squared plus a negative 10 squared. Okay, and well, that's going to be equal to, here we have a, this is just going to be 25 plus 25, that gives us 50, and then we have plus 100, which is going to give us rad 150. Okay, so that is the magnitude of A cross B. So next we need to find the magnitude of A. Okay, that's the next piece right here. Okay, and that's equal to, again, we're going to take the square root of the sum of the squares of here, right, this 1, 3, 1. So we're going to have 1 squared plus 3 squared plus 1 squared, and that's going to be equal to 1 plus 9 plus 1 under the radical. So we'll have rad 11. For the magnitude of B, we're going to have the square root of, again, the sum of the squares. So 4, 2, and negative 1. So we have 4 squared plus 2 squared plus a negative 1 squared. So we get a 16 plus 4, that's going to be 20, plus you get a 1 here, so that's going to be rad 21. All right, so now we can set this up. We have that sine theta is going to be equal to, we have that our magnitude of A cross B is rad 150. And we're going to put that over the magnitude of A, which is rad 11, over the magnitude of B, which is rad 21. Okay, and we can multiply this together and put it all under one radical if you'd like. I mean, we can kind of say that this is equal to rad 150 over, I'll do the multiplication for you here, 11 times 21 is going to give you 231. Okay, and then you get sine theta is equal to rad 150 over 231. All right, and you probably can simplify that if you take a, maybe if you take a 3 out. Let's see here. Yeah, actually that should work. But I'm not going to do that now because that's not the whole purpose of this. We just take the inverse sign on each side. We get that theta equals the sine inverse of rad 150 over 231. And there you go. That's your angle between these two vectors. Now for our next question here, we have determine if the two vectors are parallel. We have vector A, which is 693, and vector B, which is 231. Now, before we even start this, okay, we need to know that for two vectors to be parallel, the magnitude of A cross B must equal 0. Okay? That's something that you need to know before even starting this problem. Okay? That's how you figure out if these two vectors are parallel. So, what we can do is take the cross product of, or well, we can find the cross product of these two vectors, of A cross B. Okay? And what we get, when we do that, we get a 693 cross 231. And to find our cross product here, we're going to have to set up our 3 by 3 matrix. We have I hat, j hat, k hat on the top. We have 693, 231. And let's go ahead and start figuring out our determinant here. Now, we have that we're going to have I hat times, we'll have a 9 times 1 is 9, minus 3 times 3, well, that's going to be 9 as well. Okay, then we have minus j hat times, we have a 6 times 1 is 6, minus 2 times 3 is 6. Then we have plus k hat times 6 times 3 is 18, minus a 2 times 9 is 18. So you can see here that we end up with the vector 0, 0, 0. If you take the magnitude of that, we get 0. Okay, so A cross B is equal to 0, or the magnitude of A cross B is equal to 0. So that means that these two vectors are parallel. And before I end this video, if you're still uncomfortable with how I'm actually, because I'm doing the cross product a little bit faster now, okay, if you're still kind of uncomfortable with the whole idea of just finding the cross product, okay, and just the whole process behind it, I would really recommend just checking out the explanation video or maybe some practice videos on finding the cross product, okay? I think those would really help. And yeah, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors in the geometry of space, the explanation video for the uses of the cross product, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.